Hi there, class. Let's try the video in the classroom today and see how it goes. I'm going to start with reaction types. Okay, so I want you to think about your kitchen, and I want you to imagine you are cooking some food. What are you using to heat the pan? Right? There's a decent chance that you are using gas to do so. So what I've got here's this first reaction I'm going to put up here, and I'm going to turn the board so I have, I think I can try to put it all on this board. We're going to say you have propane, okay, which is C3H8. If you can't read those, send me a message. I'll try to be a little bit clearer on the video here. Sometimes I write my 8s way too fast. Okay, so it's C3H8. And in your kitchen, it's burning in air. And in air, there's something called oxygen, so O2. Okay. And after you react it, there's two products that come about. The first one is CO2. And the second one is H2O, dihydrogen monoxide. So I've got hydrocarbon plus oxygen makes carbon dioxide plus water. Do you know what type of reaction this is? This is a combustion reaction, so combustion. Alright? So what happens during a combustion reaction, this is anytime you react something with oxygen, you produce both or either carbon dioxide and water. I say both or either because you can do carbon plus oxygen to make CO2 or carbon monoxide, and you can take hydrogen and oxygen and make water. Okay, and this is what sometimes people have a hard time understanding is that combustion usually is a hydrocarbon, and you make oxygen. You can also an alcohol works too. If oxygen's thrown there, it doesn't take away from the fact that it's still a combustion reaction. Yeah, so that's the first type of reaction we know. Second type of reaction I want you to know. Let's say you take copper sulfate and you react it with zinc. And the zinc is going to be a little bit more reactive than the copper. And so you're going to produce copper plus zinc sulfate and ZnSO4. So this is copper sulfate mixed with zinc to make copper plus zinc sulfate. Okay. If you replace one thing, what are you replacing? Well, one thing is a single thing, like a single pretty on your own. You've been replaced. Okay. This is a single displacement reaction. Okay, I'm not going to write the word reaction. These are all reactions, so hopefully you can do that on your own. This is a single displacement reaction. And something a little bit more than a single displacement reaction. Let's say I have silver sulfate, and I react it with sodium chloride. I'm going to produce silver chloride and sodium sulfate. So this is a single displacement reaction. What do you think this one is? This is a double displacement. Okay. Sometimes people ask me, well, is there triple displacement? Maybe. I don't know any triple displacement reactions. The problem is just kinetically. Let's say I have an atom and I have another atom or molecule and they hit and they collide and they form a reaction. That's pretty likely. That's two things coming into contact. In order to have a triple displacement reaction, the mechanism gets a little harder. So you have to have one thing collide with another, produce a third thing, and then maybe, or all three of them have to collide at the exact same time. And that's just unlikely to happen. Okay, so I'm usually single, double, and I don't expect you to know anything other than that. Okay, so it's single displacement, double displacement. Now think about your baking. You're in your kitchen, you got this white powder, you throw it in, it breaks your bread rise. What's that white powder? That is sodium carbonate, and it becomes sodium oxide and CO2, carbon dioxide. What type of reaction do you think this is? This is when you take one thing and you turn it into two. Think dead bodies. Think food that's left in your garden. This is a decomposition reaction, okay? Something is decomposing. One thing is becoming two. Now, what is the opposite of a decomposition reaction? I'm sitting here thinking like, I don't know, recombination or composition? No, it is not a composition reaction. But let's say I take carbon dioxide and I react it with water in the presence of a catalyst, and I make C6H12O6 and oxygen. This is a synthesis reaction. Think it's business and you're talking, well, our two companies can come together. We will form great synthesis. We will become so awesome. Okay? So this is when you take two things and you make one, it's a synthesis. In this case, you're making two, but you're still making a molecule that has more structure and it has more energy to be released. So it's called a synthesis reaction. You might think to yourself, well, this is what plants do, right? This is photosynthesis, and you're not wrong. This is photo. Photo means light. So synthesis in the presence of light is a photosynthetic reaction. The most common one on Earth is this, where carbon dioxide and water make glucose and oxygen. Sometimes I like fructose and any other sugar, really. Okay, 1, 2, 3, 4, 5. There's one more reaction I want to go over here. Let's think about the two most dangerous things you'd have in a lab. Okay, one was liquid. Well, they're both going to be liquids in this case. What's dangerous? What's dangerous? We just went over names. Acids. All right, so we're going to take the dangerous hydrochloric acid and we're going to react it with, as Megan Trainor says, all about that base, no trouble. A base, sodium hydroxide. This is one of the most basic acid-base reactions you can get. This is a dangerous acid. This is a dangerous base. And we're going to react them and we're going to produce NaCl and H2O. All right, if you have something dangerous and you make it into something harmless, what do you call it? That is called neutralization. In chemistry, a neutralization reaction is when you have an acid and a base and you react them to produce salt and water. Now, NaCl is salt. Anytime you have an ionic compound, it's a salt. Okay, so in this case, it could be iron oxide, could be lead oxide, could be potassium chromate. There's anything where you have a positive ion and a negative ion that come together, they're a salt. Okay. You might also be saying to yourself, hey, this reaction kind of looks like this. Yes, a neutralization reaction is a form of double displacement reaction. So please don't forget that when you're going over your stuff here. Now, next question is, are we done with these equations? Have we explained fully what's happening here? We know what they are. This is combustion. We know that one thing replaces something else. We're not done because I have completely ignored something here called the law of conservation of mass. Okay? So the law of conservation of mass says that in any normal reaction, so a chemical reaction, matter can neither be created nor destroyed. Now I use the term normal because in a nuclear reaction, you do gain or lose a little bit of matter. What do you lose usually? It's converted to energy. Okay, so the amount of mass that goes in is not what comes out. We're not dealing with that in Gen Chem. Okay, here we're talking about if I have a carbon atom here, I need to have a carbon atom here. Okay. So we already have subscripts, okay? We have these numbers that go below. This 2 describes how many hydrogen atoms there are on this molecule. This 2 describes how many oxygen atoms there are on this molecule. How can I describe and make these bigger, right? Now, let's look at this just right. There's carbon here, there's 3 carbons, hydrogen has 8, and oxygen has 2. If I go to the other side, carbon has 1, oxygen has 3, and hydrogen has 2. Okay, so those are not the same. We have not followed the law of conservation of mass. So in order to do this, we have to balance the equation. We have to get in balance. So what we're going to do here, anytime you have a single element on its own, put the number in front of it last, okay? That is the last number for you to mess with it, okay? So what we're going to do here, see this carbon has 1, and this carbon has 3. I'm going to take a 3, and I'm going to put it in front of the molecule. And what this is saying right now is that for every 1 molecule of propane I have, it reacts with 1 molecule of oxygen to produce 3 molecules of CO2 and 1 molecule of H2O. So it's balanced in the carbons, right? This is now 3 carbons, and this is 1, and this is now 7 oxygens. So I'm much closer to be balanced than I was before. Okay. What am I going to do next? Because I'm not done. All right, so I got 2 hydrogens here and 8 here, so I'm going to put a 4 right there. And now I have 8 hydrogens on both sides. Now my oxygen here, I'm going to have 10. Right? 3 times 2 is 6. 4 times 1 is 4. 6 plus 4 is 10. So now I need to go over here, where I only have 2 oxygen atoms. It's O2, so I'm going to turn this into 5. So how you would say this is 1 molecule of propane reacts with 5 molecules of oxygen to produce 3 molecules of CO2 and 4 molecules of water. Okay? 3, 8, 10, 3, 10, 8. Okay? So the number of carbon atoms I have on the left equals the number of carbon atoms I have on the right. The cool thing about these problems, you should never get any of them wrong because you can always check your answer. Okay, you can always go and be like, oh, how many carbons are going? Carbon 3, 8, 10, 3 carbons, 10 oxygens, 8 hydrogens. You can check your answers to see if you're right or not. So that's pretty awesome. All right, next one. 1 copper, 1 sulfate, 1 zinc, 1 copper, 1 sulfate, 1 zinc. This one is balanced. We're good to go, which is normal for single displacement. Double displacement. Okay, so I've got Ag equals 2, SO4 equals 1, Na equals 1, Cl equals 1. Ag equals 1, Cl equals 1, Na equals 2, SO4 equals 1. Okay, so I've got 2, 1, 1, 1, 2, 1, 1, 1. But I have 2 sodiums here and I have 1 sodium here. So I have to increase this sodium. You can't decrease, you have to go up. Okay, so this is going to be a 2. And then I'm going to put a 2 here. And now what I have here is 1 mole of silver sulfate reacts with 2 moles of sodium chloride to produce 2 moles of silver chloride and 1 mole of sodium sulfate. Yay! Balanced! Woo! All right. Decomposition. 2 sodiums, 2 sodiums. 1 carbon, 1 carbon, 1, 2, 3 oxygens, 1, 2, 3 oxygens. Same, we're good. And decomposition usually is balanced. It's just one of those things that just because of the way things react and decompose, it usually ends up being balanced. All right, synthesis. This is going to be a little bit trickier. What I want you to do actually is try to do this on your own. So I'm gonna get to the side here. So you can see this as CO2, H2O, C6, H12O6, and O2. And I want you to pause the video and see if you can do this on your own. So. Okay, you had your chance to pause it. Now we're going to do this together. Okay, so carbon, 6 carbons here. Carbon equals 1. Carbon equals 6. So I'm going to put a 6 here. Now I've got 6 carbons. Woohoo! All right, oxygen equals 1. So this is 7. Hydrogen equals 2. It's supposed to be H. Not a very good H. I'm not good at drawing H's today. I don't know. I'm writing H's. So this H equals 12. And oxygen over here equals 8. Okay. Remember, do this last. It's on its own. So what I'm doing out here now is I have 2 hydrogens here and I need 12. So I'm going to put a 6 right there. So now what I have is I have 6 carbon dioxide molecules react with 6 water molecules to make 1 glucose molecule. And then I have an O2 right here. Here's the problem. Carbon's balanced, hydrogen is balanced, but my oxygen is not. Okay, because 6 times 2 is 12 oxygens. And then I have 6 times 1 is 6 oxygens equals 18 oxygen atoms. Okay? Here I have 6 plus 2. So I'm not going to change this prefix, because if I change carbon here, what I'm going to have happen is I'm going to have to increase these carbons. So we're going to mess with this one. But we have to subtract the 6 oxygens here. So we're going to take 18 over here. So we're going to take this 18 and we're going to minus 6. Right? So that's going to equal 12 oxygen atoms I need to account for. What number times 2 gives me 12? 12 divided by 2 is 6. So it's 6, 6, 6. For those of you who are studying biology, chemistry, environmental science, exercise science, anybody wants to go to med school, please memorize these 3 numbers because you're going to see them over and over and over again. Because you see them in biochem, you see them in biology. Because not only is this photosynthesis, if I make this a decomposition reaction and go the other way, that's human respiration. Okay? So it happens both directions. Last reaction down below, 1 hydrogen here, 1 hydrogen here, that's 2 hydrogens. Go over here, 2 hydrogens. 1 oxygen, 1 oxygen, 1 chlorine, 1 chlorine. If you ever have a acid with a single proton, single hydrogen, and a hydroxide, that's this group right here where it's just 1, they're gonna balance on their own when you react them. Sometimes you have to multiply by numbers. If this was calcium hydroxide, which is CaOH2, then the numbers would have to increase, okay? So these are the 6 reactions you should know. You should know a combustion reaction, single displacement, double displacement, decomposition, synthesis, and neutralization. And then you should understand how to balance them. If you have any questions, please let me know. This is Mr. Cubitt signing off.